Hi, we're going to start with a series of Newton's second law explanations. And today I'm going to do the simplest one there is. But before that, let's start with Newton's second law itself. Now we know that the resultant force will cause an object to accelerate. Now, the first part of the law tells us that this resultant force accelerates an object in the direction of the force. So it means that your resultant force and acceleration needs to be in the same direction. The rest of Newton's second law is about this acceleration. So let's rewrite our formula in terms of acceleration. And then we find it's F rest divided by m. So now this acceleration is directly proportional to the resultant force and inversely proportional to the mass of the object. This will then mean that if the force increases, the acceleration will increase, but if the mass increases, the acceleration will decrease. Let us look at such an easy example. First of all, we have a man exerts a force of 450 Newton to push a crate with a mass of 900 kilograms across a horizontal floor. So I have an object and I have applied force. Right, and we have the mass of our object. So first of all, the first question will be to draw a free body diagram. Now let's assume initially for the first part that there is no friction. So if we have to draw a free body diagram, we will draw the applied force, and of course we have the normal force and gravitational force. But these two forces are vertical, so they do not accelerate the object. It's only the 450 Newton that will accelerate our object. So if we look at the next question, they ask us to calculate the acceleration caused by the force if there is no friction. So let us see, using Newton's second law equation, F rest is ma, and in this case, the only force is the resultant force, which is now the applied force. There's only one force horizontally. So the 450 Newton will also now be our resultant force. And the mass is 900 kilos, and we need to calculate the acceleration. So acceleration will be 450 divided by the 900, which gives us 0.5 meters per second squared. And if we look at the direction, in this case to the right, if they don't use to the right or east, we can use the original direction of motion as our answer for direction, in the original direction. Good. Now the next question, with the same values, ask us to calculate acceleration of the crate if the floor exerts a frictional force of 80 Newton. It is very important, if you do Newton's second laws, to start with a free body diagram, even though they don't always ask you to draw it. But you need to start with the free body diagram, because the free body diagram will help you to identify the forces that will make up your resultant force. So if there's friction, these are the forces we are going to talk about. And let's just quickly revise resultant force, the definition. It is the single force that will have the same effect as the other forces together. So we have F1 plus F2. But in this case, we will see that the 450 is to the right, and the friction, which is always in the opposite direction than motion, is to the left. So one we will choose as positive and the other one we will choose as negative. So they do subtract, but it is the forces acting together. If we put everything together and we now want to calculate the acceleration, we just add that part into our formula. So we will have 450 to the right plus the negative 80 minus 80, and we have still our mass of 900 and we are calculating acceleration. So we get 370 divided by 900 will give us this acceleration. That will give us 0.41 meters per second squared. But you will see we still get a positive answer when you subtract these two. So it still means the object is moving to the right. So this acceleration is still in the original direction of motion.